Hello and welcome. In this video, we're going to be discussing how to solve word problems involving different types of variation. So let's take a look at the three types of variation that you'll be seeing. So if you see x varies directly as y, what that tells me is that x equals some sort of a constant times y. So what do I mean by a constant? Well, a constant, it just represents a number. And once I know what that number is, it stays fixed for that given situation. So for example, suppose that x represents the amount of money that you're going to pay at the register for buying a particular type of coffee. And let's say y represents the number of pounds of coffee that you're going to buy. Let's say we also know that your coffee costs $3 per pound. Well, then there's definitely a direct relationship between x and y. And the direct relationship would be the money that you're going to be spending at the register is going to equal $3 per pound times the number of pounds. So the formula we get out of that is x equals 3y. So in this particular situation, k would be 3. And no matter what x and y are, k would remain the same. The coffee's always $3 per pound. Depending on how many pounds we buy, y and x can change. But the cost per pound in this particular situation would just remain $3. Okay, if I went to buy a different type of coffee, well then your k value would change. That would be a different formula. Okay, so now if we take a look at the second one, x varies jointly as y and z. Again, that just represents a formula. So the formula this time is x equals some sort of a constant, and then times the product of y and z. So some sort of a constant times y and z. The last one, x varies inversely as y, is again a formula. This time it's going to be x equals some sort of a constant divided by y. So that last one basically represents a situation where if one variable increases, the other variable decreases. So let's take a look back at that problem. So if we start with the first sentence, it says, suppose that weight varies inversely as length and jointly as its width and the square of its height. So that first sentence actually gives us enough information to write a little formula. So if we look at just the first part of that sentence, it says weight varies inversely as length. Well, based on the background situation, I know that whenever I have inverse variation, I can write a formula out of that. So in this case, I would have the weight, which we're going to call W, equals some sort of a constant over our length, which we'll call L. Okay, if we keep reading, it says, and jointly as its width and the square of its height. Well, if I go back to the definition of jointly, remember that was a situation where if x varies jointly as y and z, we have x equals some sort of a constant times y and z. Well, we already have the constant there, so all we need to add to our formula is the variables that the weight is varying jointly as. In this case, it says it's varying jointly as its width and the square of its height. Well, I don't want to use W for width because I already used W for weight. So instead, I'm just going to use D for width. And then the square of its height, I'm just going to write that. I'm going to write height as H. And since it's the square of the height, I'm going to write that as H squared. Okay, so we finished our first step. So our first step is actually just to write a formula. Okay, step 2 then, as I mentioned in the background situation, k is a constant. So that constant is going to change depending on the situation, but for any specific situation, once k is known, it's going to stay that number. So our next step is to find k. Okay, so if we look at the next sentence, it says, suppose an object 4 inches wide, 3 inches high, and 18 feet long can support 3 tons of weight. Well, that's a lot of information there. So notice they tell us that we've got a 4-inch wide. So for us, remember we called the width D. So what they're saying is that when D equals 4, 3 inches high, that's our height, so they're saying H equals 3, and 18 feet long, they're saying L equals 18. They're saying that that object can support 3 tons of weight. So when D is 4, H is 3, and L is 18, W is 3. Well, notice that gives me basically all of the variables in my formula except for K. So what I'm going to do is I'm going to take all these values and I'm going to plug them in where they belong, and then my job is to figure out what K is. So if we plug in, we'll have W is 3, so I'll have 3 equals. On the other side, I don't know what K is, so I'm going to leave that alone. And then I've got D is 4. I've got H is 3, and remember H is squared. And then on the bottom, I have 18. Okay, if we keep going from there, my job is basically to figure out what K is. So let's clean up the top a little bit. So we have 3 equals. 3 squared is 9 times 4 is 36. So on top we've got 36K over 18. So that's a fraction that can be reduced. 36 divided by 18 is 2, so we get 3 equals 2K. And now if I solve for K by dividing both sides by 2, I get K equals 3 over 2. Okay, what that means is if I go back and look at my formula now is really W equals 3 over 2, that's my K value, times DH squared all over L. Okay, so now let's go back and read what they want us to do with that information. So if we start with the last sentence in the problem, it says, what weight could the object support if it were 7 inches wide, 4 inches high, and 6 feet long? So notice they give me 7 inches wide, they give me my D value, they give me my H value, and they give me my L value, and we're supposed to figure out what weight it could support. So what we're going to do is we're going to take all 3 of these values and plug them in where they belong, and we're going to try to figure out what W is. So step 3 then is just to plug in the information and solve for whatever it is that they want you to solve for. Okay, so I wrote out the information that we have in that last sentence. So they're saying D is 7, H is 4, and L is 6. And again, where I'm getting that from is just from this last sentence. So what weight could the object support if it were 7 inches wide? Remember, D is what we call the width, 4 inches high, and 6 feet long. So now what I'm going to do is I'm going to take our formula that now is complete because we figured out that K value, and I'm going to plug in everything that I know. So I don't know W, that's what I'm trying to figure out. So my K is just going to stay as 3 over 2. My D value is 7, and my H value is 4. And then on the bottom, my L value is 6. So if I multiply this all out, if you take a calculator and multiply all this out or do it by hand, I think you end up with W equals 28 at the end, and the units there were tons. So that is my final answer. So if we just review the steps again, our first step is to write out that generic formula based on the language that they give us. Once we figure that out, we have to figure out the K value, because for each situation, the K value is going to be a little bit different. The third step then is just to plug in what they give us and solve the problem. So here's another example. Pause the video, give it a shot, and then restart the video after you've given it a try. Okay, so our first step here again is to write out that basic formula. So if we look at just the first sentence, it says the number of cars produced varies jointly as the number of workers and the time that they work. So just based on that information, what I know is the number of cars, which I'll just call C, equals, and since it's joint variation, I know it's going to be K, some sort of a constant, times the product of the two variables mentioned. So it says jointly as the number of workers, so I'm going to call number of workers W, and the time they work, which I'll call T. Okay, so that's our first step, is just to come up with that formula. So the next step then is we want to find that K value. So if we look at the second sentence, says that 160 workers can produce 32 cars in 2 hours. So what they're saying is W equals 160, C equals 32, T equals 2. So notice that gives me all of the variables that I would need to figure out what K is. So if we plug those in, we get 32 equals K times 160 times 2. Now our job is to solve for K, so we get K, 160 times 2 is 320. So if we divide both sides by 320, I think we get K equals 1/10, or 0.1, which means our formula, if we go back to this step, is just going to be C equals 1/10 times W times T. And now let's go back and see what question they want us to answer. So it says find the number of cars that 220 workers can produce in 3 hours. So they're telling us what W is and they're telling us what T is. So the last step is let's just plug those values in. So we get C equals 1/10 times 220 times 3. And I think if you run that through your calculator or do it by hand, you end up with 66.